All right. Hey there, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is Radical Equations Part 2, which really just means that the questions are going to be a little harder, but the method is probably going to be pretty similar. And if you're like, wait, what? What are you talking about? This is part of a series of videos on Kuta software, Infinite Algebra 1, aka Algebra 1 worksheet stuff that your teacher probably sends you and is like, hey, you need to, do this for homework or classwork or both. So that's what the whole point of this series is. But without further ado, let's go ahead and jump in. If I'm doing something a little too fast, it might be because I talked about it in the last video. And so we kind of already covered it then. You can check that video out at the end of this video. And let's go ahead and get started here. The opposite of a square root is to take something to the second power or square it. And that's important because whenever we're solving any equation, we need to do what they like to call in most books opposite operations, which just means that every math thing that exists has like an opposite to it. So like plus, the opposite is minus. Times, the opposite is divide. The opposite of a square root is a square. And whenever you do the opposite operation, the opposite math thing, it cancels out the original thing. So I'm just left with 110 minus n equals n squared. Oh, well, this is interesting. Whenever you are trying to solve, normally you do the opposite of PEMDAS, right? So PEMDAS is for simplifying. If you spell PEMDAS backwards, you get SADMEP. And I've talked about this multiple times in other videos, so I won't talk about it too much. But SADMEP is how you normally solve things. But it's only if there's only one kind of variable to solve for. Because there's no way to combine n and n squared. You can't add them together, subtract them together, anything like that. So they're not like terms. They cannot be combined. So there's no way to solve using SADMEP yet. What we have to do then is we have to get everything on one side. Meaning, we have to take 110, subtract that from both sides. Okay, add n to both sides. And notice I'm going to try to space it out as I go along here, as long as I have the space. Because notice n squared isn't really going to add to n or subtract 110 from n squared or anything like that. It's just going to kind of hang out by itself because I can't combine it with these other two things. Now, don't forget that that equals 0. The equation just doesn't go away magically if you get rid of everything on one side of it. And that's the point, is we want to get it equal to 0. Because if it's equal to 0, then we try to factor, right? So this is going to involve factoring. This is pretty crazy stuff. But here's factoring, right? And I have a whole series on this. I did a whole series of this way back when. And I'm laughing because the video quality wasn't as good as it is now. I was still learning. But go check that out if you want to laugh. But here's how you factor, right? So you need to know what all the factors of 110 are. If you don't, you can always list them out, right? And I'll go ahead and do that actually for this one. Just for this one, but then in the future I won't do it like this because this is a little tedious. I want to say, no, that's 5. Just trying to do mental math and it wasn't working out there. Why can I not? Oh, 55, there we go. 3 doesn't go into 3, doesn't go into 4, does go into 5. That would be the 22. I was thinking dividing by 5, not by 2. What else? 6, 7, 8, 9, 10 goes into 10. 11 times. And I believe that's it. Now, the other thing, too, is that one of them has to be negative and one of them has to be positive. Now, we're trying to get a plus n. We're trying to get plus 1 in. The whole point of this is so that we can add up these numbers somehow and get 1. Now, obviously, if we had to add 2 positives, there's no way we'd get 1 out of all this. But we're actually going to be subtracting because one of these, if I'm going to multiply 2 numbers and get negative 110, then one of the numbers has to be negative. Thus, I'm really subtracting. I'm trying to subtract and get 1. So let's put negatives here. If you're trying to subtract and get a positive number, then you'll want to put negatives on the left side with your smaller numbers, because that'll give you a positive number when you subtract. If you wanted a negative, then you'd put a negative sign on the bigger numbers, because if you put two numbers together, one of them's negative, the negative's bigger, results in a negative. All right, there's a lot going on there, and factoring can be really tedious and really confusing, but it doesn't have to be. And here's why. Negative 10, right? These would all have to be pluses, right? Negative 10 plus 11. It's the same thing as 11 minus 10. 11 minus 10 is 1. Therefore, we've found the factor. This is the hardest part of factoring, is finding the factors. Once you do that, you're basically done. Watch. In. Remember, that equaled 0. And then, basically, we have the answer. So the reason why this is basically already the answer is because when we have two things in parentheses, what we're saying is I'm going to multiply two things and get 0. Well, the only way to multiply two numbers and get 0 is if one of them is 0. So either n minus 10 is 0, or n plus 11 is 0. That's the only way. It could be either one or both. It could be both. That's why we're using both of them and setting them both equal to 0. If either of those things in parentheses is equal to 0, then it multiplies by any other number and gets 0. So that means that n, if I add 10 to both sides, n is 10, and n is also negative 11. Okay, those are my two answers. Now, we want to be careful here because we want to make sure that when we plug them back in, they work. That's really important because sometimes you end up with what's called an extraneous solution. An extraneous solution is when you didn't do any math wrong. You didn't do anything wrong. The number just didn't work. And it just happens. It's just a great mystery of mathematics. You didn't do any math wrong. You just plug it back in and it's just like, it just yeets you. You get yeeted. So n equals 10. Let's see if that works. N equals 10. 110 minus 10 is 100. The square root of 100 is 10. Check. That works. What about negative 11, though? Let's think about this. Negative 11. 110 minus negative 11. Okay. 110 minus negative 11. That'd be 110 plus 11, which is 121. The square root of that is 11. Oh, that almost seems like it would work, but 11, if I take the square root of all that, I did all that math in my head, so if you weren't following, that's okay. When I plug in negative 11 on the left side of the equals, I get 11. But that's supposed to be equal to n, which is negative 11. That doesn't work. We got really close, really close. But 11 does not equal negative 11. Therefore, this is an extraneous solution. N equals negative 11 is an extraneous solution. Wow. And that was just number one. So what I'm going to do is, obviously I took up like 3 different spaces of problems here. So as I move forward, I'm not going to do as much work. I'm not going to do as much showing of my work, because it's just going to take up a ton of space, and you can always refer back to number 1. Now for number 2, we'll still show most of everything, but as we move along, I'm not going to show as much work. 1, because of, just there's no space to do that. And then 2, once you start to get the hang of it, it's going to be kind of annoying if you start to get the hang of this and you're like, oh, he's showing every single step still. Because eventually you want to not have to do all these steps. You want to be able to just, get the answer in less than a minute. So let's go ahead and move on to number 2. We're going to start off the same exact way as number 1. Square both sides. So p squared equals 2 minus p. The square root and the square cancel. Okay, I want to move everything on one side. So I'm actually going to do, I got p squared. And what I like to do is I like to move everything to the side that has the positive squared term. Just because when you're factoring, if there's a negative in front of your square term, then you actually have to do a more complicated version of factoring. So if you're new to factoring, yes, there are harder versions of factoring than what we just did on number 1. And we want to avoid those if at all possible, because this kind of factoring that I just showed you in number 1 is actually the easiest kind of factoring out of all the factorings, except for maybe like the difference of squares. But you don't really have to factor that because you don't have two different kinds of variables. So anyways, we would be adding p to both sides, plus p. We would be subtracting 2 on both sides, and then that equals 0. Okay, I would subtract 2 on both sides, gets rid of the 2 on the right. I would add p to both sides, gets rid of the p on the right, kind of moves it over to the left, so to speak. It's not really moving per se, but we like to say moving sometimes because it's just easier. Then I want two factors. Well, there's only two factors of 2, 1 and 2. Right? It has way less factors than 110. So actually, these are the only two factors, 1 and 2. And I need to subtract again and get 1. So there we go. -1 and +2. I'm sorry, I'm kind of squeezing this in here. So p minus 1 equals 0. That means p equals 1. P plus 2 equals 0. That means p equals -2. Okay? And it's not always the negative that's the problem. It can be the positive that's the problem. So I don't know if you noticed that pattern. If you, well, I mean, we have only done one so far, but the negative isn't always the issue. I would say it's more likely than not the issue, but it's not always the issue. So just plug both in just to be careful. Okay? If I plug in 1, 2 minus 1 is 1, the square root of 1 is 1, 1 equals 1, check. Good to go. If I plug in -2, 2 minus -2 is 4, square root of 4 is 2, but 2 has to equal -2. That doesn't work. It ends up having the same issue that number 1 did. Extraneous solution. Okay? All right, moving on. So if you've never seen a video like this before, I like to keep switching colors. Just to keep it a little bit alive here, I'll just keep switching colors every 2 problems. Just to I'm not like trying to color code or anything. I'm just switching up colors to try to keep things a little more lively here. So that's all this is. So square, square, squares cancel. Square and square root cancel is what I mean to say. 30 minus x equals x squared. I'm going to move everything onto the right-hand side. Again, move is used very lightly here. Plus x, I'd have to add x to both sides. I'd have to subtract 30 on both sides. Now, I want two factors of 30 that add to 1, ultimately. Okay? So if you're new to factoring, then it would be helpful to just write out all the factors of the number and then find the factors, and then subtract all the factors or add all the factors, and then pick from there which one gets you to the number in the middle. If you're new to factoring, that's kind of what I did here, except this would have been 109, this would have been 53, this would have been 17, this would have been 1, right? So on and so on. I'm going to scratch that out because it's going to look like it equals 1 instead of 0. But all of those would have equaled something. And then you figure out, oh, hey, if -10 plus 11 is 1, then that's the two factors that I need. Okay, so you can do that as well if you need to. But eventually, you want to be able to not have to do that because it just takes up more time, and factoring takes a lot of time anyways. So what I'm getting at is I want two factors of 30. Right? So try to think of all the factors of 30. It has a lot of factors, right? 1 and 30, 2 and 15, 3 and 10, 5 and 6, right? I believe that's all of them. So we want the two numbers to subtract and get 1. Well, if you want two numbers to subtract and get 1, they need to be pretty close, right? So 5 and 6, there we go. We need the 5 to be negative, the 6 to be positive. That way, -5 plus 6 or 6 minus 5 is 1. Then I throw x's in front. X, right? That equals 0. And if that equals 0, then x must equal 5 or -6. Right? So x equals 5 or -6. Okay? Either one, but we have to make sure we know which one it is equal to, and it looks like that negative is not going to work out again. 30 minus 5 is 25. The square root of 25 is 5. That works. But -6, we end up with that same problem. We get 6 equals -6. That doesn't work. Okay, so x equals 5 only, and then we're done there. All right, moving on. Square, square. X squared equals 8x. All right, notice this time we only have two terms. Now, we still have to factor, but we don't have to do this kind of factoring. Actually, you know what? Earlier, when I said this was the easiest kind of factoring, I unintentionally lied because there is one kind of factoring that's easier than the factoring we did on number one, and that's the greatest common factor. Factoring out the GCF, factoring out the greatest common factor. That's the easiest kind of factoring, and that's what we're about to do here, because if there's not three terms, if it's not a trinomial, then we don't have to try to do the whole what two numbers multiply to the other number and then subtract or add to the middle number, all that stuff. We actually can just factor out x. They both have x in common. When I factor out x, I'm dividing. Factoring is dividing. So when I factor out x, I'm dividing x. So x squared divided by x is x. Minus 8x divided by x is minus 8. Then I have my two answers. I have x equals 0, right? If x is 0, then 0 times anything is 0, right? This is just 0, or 8. And I believe both answers might work here, because if you think about it, if I plug in 0, 0 times 8 is 0, the square root of 0 is 0. I can take the square root of 0. That's possible. So 0 works, actually. And then 8 works as well, because 8 times 8 is 64, square root of 64 is 8. 8 equals 8. Yeah, they both work. Look at that. All right, we're going to change colors again. And notice as we move on, I'm not going to show as much work. I'm going to start to go a little faster as we go here. So let's square, cancel. X squared equals 42 minus x. We want to move everything to one side, so we're going to do add x minus 42 equals 0. Okay, we subtract 42 to both sides. We add x to both sides. We get everything equal to 0. We had to do that because there's two different kinds of x's, two different kinds of variables. Right? 42 is 6 times 7. 6, 7. We want the 6 to be negative and the 7 to be positive, because negative 6 plus 7 is positive 1. Positive 1 is the number in front of x. And that is how you factor. So then we end up with two answers. We get x equals 6 or negative 7. And the negative 7 thing is not going to work, because we get, a positive 7 equals a negative 7 again. So that's not going to work. The 6 looks like it works. 42 minus 6 is 36. Square root of 36 is 6. So that looks like that works. Cool. Nothing really new just yet. Number 5 wasn't really anything new, so I'm going a little bit faster there. All right, r squared plus r minus 12 equals 0. 12 is 3 times 4. Again, we want to do minus 3 positive 4 to get positive 1. Oh, I put x there. I meant to put r. It's going a little fast. Not that it matters too much, but some teachers can be really picky. You want to make sure you put the same variables that you started with. So r is equal to 3 or negative 4. Okay? And I'm doing that a little faster as well, because notice when you have things in parentheses like this, and you just have the variable plus or minus the number, the answer is always the opposite of the number. So you don't really have to solve it. You don't have to be like, oh, r minus 3 equals 0. Add 3 to both sides. Oh, r equals 3. Notice patterns, and then when you notice a pattern, use that as a shortcut to get to the answer faster. Okay, it's especially helpful on time tests like, the SAT and things like that. So, oh, and we didn't eliminate the extraneous solution. It looks like it's going to be that negative 4 again. Yeah, because that's going to be 16. Square root of 16 is 4. 4 equals negative 4. No, 4 does not equal negative 4. R equals 3 is the only answer. All right, moving on to the next color. Looks like we're going to do that thing again. So this is 4n equals n squared. N squared minus 4n equals 0. N minus 4. This is the same thing as number 4, right? There's only one thing inside of that radical, so we end up just having to factor out a greatest common factor. And if you were wondering, hey, why don't we just do a GCF on this other stuff and make our lives a lot easier? Well, we would, and you do want to do a GCF first if you can, but that's the thing. You can't. If there's 3 things, right now we haven't come across any 3 things where they all have something in common. All 3 things. Right? So like x squared plus 1x minus 30, they don't all have an x. They don't all have a 2 or a 3 or some other factor of 30. So we can't take out a GCF, right? GCF has to be taken out of everything. So that's why we don't normally have the ability to do that. So n equals 0 or 4, and both work again, right? This is going to be exactly like the other one. 5v equals v squared. V squared minus 5v equals 0. V minus 5 equals 0. So v equals 0 or 5. Okay, and you can kind of just see, like, as we let's look at this next one, right? So we've been doing a couple of these already, and I think you maybe have noticed a pattern. Like if we go up here, 8x, the answer was 0 and 8. 4n, the answer was 0 and 4. 5v, the answer was 0 and 5. So this one, the answer is going to be 0 and 10. And if you guessed it, good job. Let me know in the comments if you guessed the answers to this without having to do any work. Right? That's the pattern. Look for patterns, and when you see the pattern, do the answer, right? Now, if you need to show the work because your teacher, knows that you could potentially look up the answers to this worksheet and, just put all the answers down and get credit, and they want you to show your work, one, because it's good to show your work anyways, and two, because they don't want you to just look up the answers and not have to do any work to get 100% on this worksheet. Then, for number 9, do some work. Do the same thing that we did for number 7 and number 8. But I'm just saying there's a pattern. If all you need is the answer, then just use the pattern to get the answer. All right, anyways. Square, square, cancels. M squared equals 56 minus m. M squared plus m minus 56 equals 0. 56 is 8 times 7. So 7 and 8. We need minus 7 and positive 8, which means m is going to be equal to 7 or negative 8. And the negative 8 won't work. 7 does. There's the answer. All right, so as we go along, notice there's a pattern, right? It's always the same. Like right here, number 12, I'm going to skip to number 12. Look at that, 0 and 8. Boom, done. It's exactly like number 9. All right, this one, square, square. B squared equals negative 4 plus 4b. B squared equals, not equals. Lo siento. Un momento. B squared minus 4b plus 4. Normally we have to subtract. This time we're not. It's 2, 2. But 2 plus 2 is positive 4. We need to add 2 negative 2's to get negative 4. This is the first time we've come across this kind of factoring. It still works, though. I need to multiply to get positive 4. I can multiply negative 2 times negative 2 to get positive 4, right? Negative times a negative is a positive. But then if I add negative 2 and negative 2, I get negative 4. So that works. B equals 0, so B equals 2 is the only answer. There's 2 B minus 2's, so there's only one answer. Now we want to, still check it. So if we plug into, let's see, plug into 2 times 4 is 8. 8 minus 4, or negative 4 plus 8, which is 4. Square root of that is 2. Yeah, that works. All right. That was an interesting one. Moving on to the next color. Got like a goldish kind of color here. Square, square. Negative 16 plus 10a equals a squared. A squared minus 10a plus 16 equals 0. 16 is 2 times 8. And we want 2 negatives. We have the same thing as number 11 here. We need to make them both negative. That way they multiply to a positive and they add to a bigger negative, aka negative 10. Boom, boom. And we get 2 and 8. Let's see if they both work here. So 2 times 10 is 20. 20 plus negative 16 would be 4. Square root of 4 is 2. Yeah, that works. And then 8 times 10 is 80. 80 minus 16, 70, 64. Square root of that is 8. Yeah, cool. They both work. All right, next, square, square. R squared equals negative 1 minus 2r. r squared equals 2r plus 1. R squared equals, oh, wait, hold on. I'm going a little too fast again. R squared plus 2r plus 1 equals 0. There we go. Trying to erase. Aha! Okay, so r squared, oh, and actually, this is just going to be 1 and 1. So r plus 1, r plus 1. So r equals negative 1. Let's see if that even works, though. If we plug in negative 1 times negative 2 is positive 2 minus 1 is 1, square root of 1 is 1, but then that equals negative 1. That doesn't work. There's no answer to that. There's no answer to this problem. And that just happens sometimes. Sometimes there is no answer. Notice that we've either had 0 answers. This is the first time we've had 0 answers, 14. Sometimes we have 1 answer, like number 11, right? Or like number 1. There's only 1 answer. The other answer was extraneous. So sometimes we only have 1 answer. Sometimes we have 2 answers, though. Like number 4, that was the first time we had 2 answers. So that's the only amount of answers that you can possibly have, is 0, 1, or 2. If you get 3 answers, that's a red flag. You should not get 3 answers. It's not possible. Okay. You also can't get a negative number of answers, but I don't know if you would struggle with that or not. So yeah, if you get any more than 2 answers, then you're definitely doing something wrong. Negative 45 plus 14n equals n squared. N squared minus 14n plus 45 equals 0. Let's see, we need to add 2 things. 9 and 5. 9 and 5. Okay, and then since they're both positive, it looks like they'll both work. 9 times 14, 5 times 14, and then you subtract the 45. Yeah, they look like they both work. N equals 5 and 9. Okay, I didn't check them this time just because normally, unless something looks really unusual, the positive answers are going to be good to go. If we see some weird negatives in some weird places, then it might be the reverse. That's what I was referring to earlier. The negatives aren't always extraneous, but usually they are, unless the problem just looks really weird. Okay, x squared plus x minus 110. This is the same as before. And then number 1, actually, 10 and 11, except we want that to be negative. So then we get x equals 10 and negative 11. The negative 11 won't work. So we just end up with 10. That's actually like, is that the same thing as number 1? I'm kind of curious now. Yeah, 110 minus n. Yeah, it's the same exact thing. They just have the right side on the left and the left on the right, and they switch the letters from n to x. Yeah, same exact problem. Come on, guys. Let's be more original. Square, square. Oh, wait, hold on. This is the same as before. Well, I might as well go ahead and finish it now. N squared minus 9n. N minus 9, n equals 0 or 9. All right, boom. And again, that was one of those ones where, you can kind of just look at it and be like, oh, hey, I know what the answer is, because it's just like the ones before it. X squared equals 40 minus 3x. X squared plus 3x minus 40 equals 0. We need 2 things that multiply to 40 and subtract to 3 since it's negative 40. 4 and 10? No. 2 and 20? No. We need something a little closer. How about 8 and 5? Yeah, that should work. 5, 8. We need the 5 to be negative, 8 to be positive. That way we get positive 3. Boom, 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 boom. It's really important you get the signs right, because if you mix up the signs, let's say you said x plus 5, x minus 8, that would still multiply to negative 40, but then it would add to negative 3, and you'd get the opposite of the right answer. Which is, it had a double meaning unintentionally. You get the opposite of the right answer, which means you get the wrong answer. But it also means, you literally get the opposite of the right answer. So be really careful with your signs. It's really easy to miss a sign. Negative signs are deceptively tricky sometimes. So x is equal to either 5 or negative 8. And it looks like that negative 8 isn't going to work out. There we go. Okay, moving on. Next two. Square, square. 90 minus n equals n squared. N squared plus n minus 90 equals 0. In, this is negative 90, so I want 9 and 10, so we want plus 10 minus 9. So n is going to be equal to negative 10 and positive 9. It looks like that negative 10 is not going to work out, so 9 is the only answer. Square, square. X squared. Let's go a little faster, just for a little challenge here. We'd have to subtract the 17, right? So minus 17x plus 70 equals 0. And then 70 is 7 and 10, so it'd be x minus 7, x minus 10, which means it's 7 and 10. Since those are both positive, it looks like that's going to work out. I did say both positive. Talking a little fast here. 17 times 7, that seems like that should be fine. 17 times 10 is 170, minus 70 is 10. Yeah, that works. And the 7 should work. I don't remember what 17 times 7 is off the top of my head. I don't have that one memorized. 9, 4, 7, 1, 1, 119 minus 70. So 119 minus 70. So 1, 1 and 7, 4, 49, 7. Yeah, that works. Okay. Now notice I'm doing all of that in my head. You don't have to, do it all in your head. I'm just doing that a little faster because it is important to check your answers to make sure you have the right answer. If it's just on a worksheet, I would check some answers just for the practice of it, but I wouldn't check all the answers just because it's really tedious and you can kind of get the pattern. Now, if it's a test and if your tests are worth a lot in class, like 40% or more of your grade, oh, hey, this is a new question, but before we get to this, if your tests are worth like 40% or more of your grade, I would probably check all of the answers just to be safe because, 40% is pretty hefty. So yeah, number 21. This is different because I have to put parentheses around this. This is a little different. This is not normal. I have to put parentheses around that n plus 3 because when you square both sides, just like when you multiply both sides, you know how like when you divide both sides, you have to divide like everything. So it almost seems like you're dividing like 3 times on the right and only 1 time on the left. And that seems weird, but when you think about it, you're dividing the whole thing. So sometimes you just have to individually divide numbers. Well, that's kind of what's happening here. We have to square the whole side, the whole left side and the whole right side. Well, the whole left side is all kind of grouped together here. So we get 4n plus 8. The whole right side, though, is n plus 3 squared, but that's not distributed. Do not distribute a square into things that are added or subtracted. That's a big no-no. You'll get close to the right answer, but not quite, because n plus 3 squared means n plus 3 times n plus 3. We actually have some foiling to do. We have to FOIL and then refactor, right? This is going to be a little crazy. Let's go ahead and FOIL this out. First times the first. Outer times the outer. Inner times the inner. Last times the last. Okay, that equals 4n plus 8. We still want to get everything on one side because we have an n squared and an n. So we subtract 8. Subtract 8. Subtract 4n. Subtract 4n. Right, so all that equals 0. N squared. 3n plus 3n is 6n minus 4n is 2n. Positive 2n. 9 minus 8 is 1. All right, so then we just end up with n plus 1. N plus 1 equals 0. So n equals negative 1 is the only possible answer, but we have to check to make sure that works. Now, notice before I was saying negatives normally don't work, but let's look. Let's look here for a second. If we plug in negative 1, starting on the left-hand side, 4 times negative 1 is negative 4. Okay, negative 4 plus 8 is 4. The square root of 4 is 2. So on the left-hand side of the equation for number 21, we have 2, positive 2. Well, if I plug in negative 1 on the right-hand side, negative 1 plus 3, that's also positive 2. So actually, this works. This is the first time that a negative answer works. Okay, so remember what I was saying. Negative answers usually don't work, but sometimes they do. So you have to be careful. Don't discount any negative answer as the wrong answer when you're doing these things. sometimes negative answers do work. And this problem was very different than the others, which is one of the reasons why that negative worked. Okay. Now, 21 is different because we had to square both sides. We had to FOIL and then factor. 22 is also different, though, because this is the first time we have not had the square root stuff all by itself. Here's what I mean. Number 19, square root, all on the left side, nothing else there. 17, square root, all on the left side, nothing else there. Where's the square root on the right? How about number 18? Square root, all on the right side, nothing else but the square root. Okay, so number 22 is different even than number 21. We have to SAD-MEP, right? SAD-MEP is coming up again. We have to solve a little and get the square root by itself. Now we've got the square root by itself, and now it looks just like number 21, okay? So then we have 6n plus 19 equals n plus 2 squared. Now, I'm gonna blow your mind a little bit, maybe. If you already know about this, then awesome. Let me know in the comments, by the way, if you already knew this little trick. But whenever you're squaring, it's gonna be the first thing squared, okay? It's gonna be the last thing squared. Right? First thing squared, last thing squared. That is a thing, right? So it's kind of like distributing. That's why I said it was close. It's close. But there's a middle thing as well. Notice over here, n plus 3 squared. We ended up with 2 3n's, which ended up to be 6n. There's always going to be 2 of whatever the number is with the variable. So there's going to be 2 2n's. Well, that means there's going to be a 4n there. That always works out like that. So here's how you do it. You take the first thing, right? So a plus b. Here's what you do. It's always a squared plus 2ab plus b squared. Meaning, multiply the first thing by itself, then do 2 times the first thing times the second thing. Then do the last thing times itself. And then you're good to go. Okay, a little shortcut. We want to get everything on one side, so 0 equals n squared. Okay, there's not n squareds on both sides. We're going to subtract 6n on both sides. That's minus 2n. We're going to subtract 19. So that's going to be minus 15. Yeah, minus 15. And then we have 3 and 5. 3 and 5 work. N minus 5. N plus 3. Okay, minus 5 times plus 3 is negative 15. Minus 5 plus 3 is negative 2. N equals either 5 or negative 3. Now, we have to plug it back in to make sure it works. It needs to be equal to positive 2. So if I plug in 5 times 6 is 30. 30 plus 19 is 49. Square root of that is 7. 7 plus negative 5 is positive 2. Okay, that works. And negative 3. Negative 3 times 6 is negative 18. Negative 18 plus 9 is 1. The square root of 1 is 1. 1 plus the opposite of negative 3. So 1 plus 3 would be 4. Oh, that doesn't work. Let's look at that one more time. Because, I mean, if you look here, it's negative 3 has to be plugged in for negative n. So it's negative 3, which is positive 3. So think about it. If I plug in, it's got to be positive 3. 3 plus something equals 2. Well, the smallest square root thingy can ever be is 0. So, yeah, that doesn't work. And you're probably like, oh, yeah, well, that's negative, so obviously it doesn't work. But I think you can agree. Number 22 is the most difficult one we've had so far. Like, it wasn't necessarily obvious that the negative wasn't going to work there, okay? It's a pretty complicated problem. We got to make sure both answers work there. Okay, so square root negative 3m plus 10 equals m minus 4. Okay, square that. Negative 3m plus 10 equals m squared minus 8m plus 16. All right, square the first thing. 2 times m times negative 4. And then negative 4 times negative 4 is positive 16. Okay. 0 equals m squared. I'm going to add 3m, so minus 5m. I'm going to subtract 10. And then 6 is 2 and 3. So m minus 2, m minus 3. Okay, adds to negative 5, multiplies to positive 6. M equals 2 or 3. Okay. And I think 2 and 3 should both work. Let's see. So, well, actually, maybe not. I don't know if either of them will, actually, now that I think about it. 2 times negative 3 is negative 6, plus 10 is 4, square root of 4 is 2, 2 plus 4 is 6. That doesn't work. Nope. And then 3 isn't going to work either. And the reason why neither of those are going to work, actually, is because I need to add 4. Like the lowest the square root thing can be is 0, right? Because you can't take a square root of a negative number. So the lowest a square root can be is 0. And I'm going to have to add 4 to something that's at least 0 and get 2 or 3. That doesn't work. You can't add 4 to a positive number and get 2 or 3. That doesn't work. So neither of these works, actually. No answer. No solution. All right, this one, number 24, is actually just a little bit simpler than the previous two we've just done. X squared minus 10x plus 25 equals x plus 1. X squared, we're going to subtract x on both sides, so 11x. We're going to subtract 1 on both sides, so plus 24. 24 is 8 and 3. We need them both to be negative. 3 times 8 is 24. Negative 3 and negative 8 make negative 11, so x is going to be either 3 or 8. Looks like 3 is not going to work because 3 minus 5 is negative 2. If I do that on the left-hand side, right? So on the left-hand side, 3 minus 5 is negative 2, and a square root can never equal a negative. So 3 is out. 8 looks like it should be fine. 8 minus 5 is 3. 8 plus 1 is 9. Square root of 9 is 3. So that works. All right. Oof, these are quite a doozy here. How many more do we have left? Just 4. All right, we're rounding off the end of it here. I know this has been a little crazy, guys, but thanks for hanging out with me. If you haven't already gotten my awesome free guide, it's the 5 math mistakes everyone makes and how to avoid them. It is, obviously it's just a free guide that I made in order for you guys to know what some common math mistakes are or were, and what you can do in the future to avoid those mistakes and start getting the right answer on your math problems, right? So another title that I have is Never Make Another Math Mistake, meaning follow the guide that I have and you'll be on your way to getting math questions right, which is pretty awesome. So go check that out. It's on my website, Myers Mathematics. The link is in the description below. All right, so that's going to be 70. 70 is 7 and 10. 7 and 10 minus minus, boom, 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 equals 0. So then we end up with 7 and 10. Looks like if I do 7, that equals 0. But that's fine because I can take a square root and get 0. 7 minus 7 is 0. Okay. 7 times 3 is 21. 21 minus 21 is 0. Square root of 0 is 0. Yeah, actually, that actually works. And then 10 minus 7 is 3. So left-hand side, 3. 10 times 3 is 30. 30 minus 21 is 9. Square root of 9 is 3. So that works. Both work. All right. Boom, boom. Square, square. B squared minus 12b plus 36 equals 18 minus 3b. B squared. We're going to add 3b to both sides. And we're going to subtract 18. That's actually going to be 18 because 36 is 18 plus 18. That equals 0. This is going to be b. Let's see, it's going to be 6 and 3. b, 6 and 3. So the answers are going to be 3 and 6. If I do 3 minus 6, that's negative, so that's not going to work. If I do 6 minus 6, that's 0, and that's fine because on the right-hand side it looks like I get 0 as well. All right, and rounding off the last two, here we go with like a dark, dark purple. So we want to, add 3 to both sides first, right? So m plus 59. M plus 3. And I paused for a second there because I was wondering if I could just stop right off the bat and say there's no answer. I don't know necessarily if I know that right now. So let's check it out. So that goes away there. This is m squared plus 6m plus 9. All right, we want to add or subtract something on both sides so that we get everything on one side. So we're going to subtract m on both sides, so plus 5m. We're going to subtract 59, so minus 50. So let's see, 5 and 10. Yeah, that should work. 5 and 10. We're going to get positive 5. Boom, 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 boom. So m should be 5 or negative 10. Okay. So let's see, 5. 5 plus 59. That's 64. Square root of 64 is 8. 8 minus 3 is 5. That works. Negative 10. Okay, negative 10 plus 59 is 49. Square root of 49 is 7. 7 minus 3 is 4. That did not work out. That was kind of weird. Normally, it's like you get a number equals a negative version of itself, but that just didn't work out. Negative 10 plus 59 is 49. Square root of 49 is 7. 7 minus 3 is 4. Yeah, that doesn't work out at all. So there's the answer. Square. Oh, wait. Too soon. Little a is hanging out there. The a is not under the square root thingy, so I have to add that to both sides. That was tricky. I almost got duped. 7a minus 54 equals a minus 6. I like to put the a thing first. Square, square. 7a minus 54 equals a squared minus 12a plus 36. 0 equals a squared. We want to subtract 7a from both sides, so minus 19a. We want to add 54 to both sides, 5, 3, 8, 9. And I'm actually going to have to use the next page a little bit. Hope you don't mind running out of space here. 9 is going to be 9 and 10. All right, 9 and 10. We want a negative 19. Oh, wait, hold on. Yeah, no, we're good. We want to add. So we want negative, negative. Aha, there we go. Okay. So A equals 0. So we end up with 9 and 10 as answers. We have to make sure they work. Let's see if they work. 9 times 7 is 63. Minus 54 is 9. Square root of 9 is 3. 3 minus 9 is negative 6. Yeah, that works. Okay, 10. 10 times 7 is 70. 70 minus 54 is 16. Square root of 16 is 4. 4 minus 10 is also negative 6. Okay, yeah. They both work. I was not expecting those both to work. All right, and here are the answers. By the way, you don't need to look up my videos to find all the answers. The answers are right at the edge of your fingertips. Whatever worksheet you've been given by your teacher, you can just pull it up. Just Google it. Google the worksheet and you'll find the answers that way. That's why teachers normally are like, oh, hey, show your work. Because they know that you could probably look up these worksheets and find the answers, right? So here's all the answers. And if that was too fast, you can always pause, rewind, go back, double speed, whatever you want to do to get all those answers that you might have missed. Or you can just Google it yourself and find the answers to the worksheet. But here it is. This is it. And also, if you have watched another video and you were wondering, hey, can I just get the whole thing, like with all your work in it? Yeah, definitely. I save all of these. I don't know if you knew that, but I save all of these as PDFs. So if you want this, just shoot me an email. My email's in the description below, and be like, hey, I'd love to get all the answers to this, and I would love to send it to you. So just shoot me an email, and I'll send that over, right? And that's true with any of these, not just this one, any of these videos, okay? And that's it for today. So like, comment, subscribe, all that good stuff. And you should be seeing those cards at the bottom left, bottom right, and a little button to subscribe, all that kind of stuff. The video that I'll probably put in there will be Radical Equations Part 1, just in case I was going a little fast. And the other thing will be a playlist. It is the Algebra 1 playlist. Like all of the Algebra 1 worksheets, they're all on that playlist, okay? At least so far, if you're watching this and I haven't finished this series yet. So go check that out. Hope it's been fun. Hope you've had fun. I've had some fun. And I'll see you again in another episode.